quadratic sequences. So let's look at this worded type of question and let's try to figure out what it's saying to us over here. And press play when you have finished. Now the nth term of a sequence is given by an squared plus bn. Okay, so there's no c integer over here, we're noticing. A and b are integers. The second term of the sequence is 2, and the fourth term is respectively 20. Find the sixth term of the sequence. Now this is very similar to something called a simultaneous equation, okay? It's giving scope to that because we have two sentences over here. In fact, let's color code this again. Let's call this yellow, the second term of the sequence, which makes us think we're going to plug in n equals 2 because it's the second term. And the second sentence, should we say, is the fourth term is 20. Okay, so n is 4, plug in n is 4. That's coming to our mind straight away. Let's see what we mean by this. So second term of the sequence. Now this is the sequence over here. We have y equals an squared plus bn. We want to find out a and b, and that's it. Second term is this. So the second term, okay, that means basically n equals 2. All right, so if we do that, let's plug in n equals 2 into this. So a times 2 squared plus b times 2. That 2 squared is simply going to be 4. So it's 4a plus b times 2, or 2b, equals 2. This 2 is this 2 over here, because it equals that number. The same thing, we could say the fourth term is when n equals 4. Okay, that's in the same way. We could say, if you plug in 4 into here, or here rather, 4 squared is 16. So 16a plus 4b, because n is 4. Okay, 4 times b, or b times 4, will equal this number over here, 20. Okay, it's simultaneous because a and b are the unknowns, just like x and y would be anyway. Now, if we have this, let's try to find out a and b. We can call this number 1 and number 2 if you want to. So this is an advanced simultaneous, so we're going to be multiplying. In fact, let's write everything from scratch over here. It's a bit neater on the eye because we can't really make much sense of that. 16a plus 4b equals 20. Okay, advanced simultaneous because none of these numbers, or coefficients rather, are the same. Let's create a new type over here, and we'll do the same thing as a simultaneous. We're going to multiply everything on the top row by 2, and this by 1. We can keep it the same. So this will be 8a plus 4b equals 4. We simply multiply this by 1, leave it the same. And the whole point is to make the b coefficients the same, which we have done that. That's what multiplied it by 2, by the way. Let's now take them away from each other. We'll do the bottom row take away the top row because it looks a bit easier to do that. So 2 take away 1. 16a take away 8a will give us 8a forward slash 16. A equals 16 divided by 8, which is 2. Therefore, a equals 2. Let's sum this into the easiest equation. Let's call this part 1. So if a is 2, it's 4 times 2. 4 times 2 plus 2b equals 2. 8 plus 2b equals 2. 2b equals 2 minus 8. 2b equals minus 6. So b is minus 3. So a is 2 and b is minus 3. Those are final coefficients for this quadratic sequence. We can now find the, well, let's first of all plug this into our original equation, quadratic sequence. We'll do it over here. We have y equals 2n squared, if a is 2, minus 3n. That is the final equation. Let's find the sixth term now. This is like a part B question in a way. We're just simply subbing in a value of n into this to find the sixth term when n is 6. Now if n is 6, if n is 6, it's going to be 2 times 6 squared, take away 3 times 6. Do a bit of bit mass, indices first. 6 squared is 36, let's double that. 72, take away 18, answer is 54. So that is the final answer for this in two parts already. The first part was finding the quadratic sequence, i.e. the coefficients a and b. Second part, plugging for any nth term you wanted to. In this case, the n was 6, and that's how we got 54.
Let's write this question down now, part A, and find the values of a and b for both of these different kind of functions, f and g. Press play when you have completed this question. Now let's read the question. It looks quite complicated over here, but really if we split this down and know the technique to use, it's not that bad at all. So g of 2 equals 10. Okay, that's the first kind of statement we're given over here. And f minus 1, 18, or the inverse function of f, 18, equals g of 1. Let's look at this and let's try to sub in what we have so far, step by step. So g of 2 equals 10. So that means we sub in, wherever we see x, we plug in 2. So if we do that, we're going to plug in 2 on here. We get a2 or 2a. So g2 equals 2a plus b. We can't go any further. We'll leave it like that. That's the first step over here. We've dealt with the first kind of statement over there. We'll call that a yellow one. Let's look at the green one over here now. So we have this inverse function of f and then 18. So let's first of all plug in find first of all the inverse function of x. The 3 steps. Step 1, we'll call this y. Y equals 4x plus 2. Step 2, we'll make x a subject, so it'll be y minus 2 all over 4 will equal the value of x. Step 3 will simply replace x for y and y for x. Okay, the variables, so x minus 2 all over 4 equals f minus 1x. So this is our inverse function over here. That's to do with this statement, the second statement, so we'll call it green. Okay, this is what we have over here. Now you want to actually plug in 18 into this, because that's what the question is asking. It's saying x is going to be 18. All right, so if x is 18, because of 18 over here, we'll say basically that 18 minus 2 all over 4, that's the same thing as the inverse function of f, and that should be 18, like that. Okay, so we get 18 minus 2 divided by 4 is simply 16. So f minus 1, 18 will give you 4. Okay, so we've got that. Now this equals G1. So G1 simply is like wherever we see x, we're going to plug in 1. So G of 1 simply equals a times 1, or 1a, or simply a plus b. So we have that equation over here. So let's put the two together now. Let's see what we can do with the yellow color and the green color together and what they look like. That's very important to identify what they look like. We have this. We have basically, this equals 10 in fact. We forgot to put that. That's the 10 over here. So we have this over here, 2a plus b equals 10. Now that looks like a simultaneous equation, first of all, okay? So if we have this in the same format over here, it'll be really good. So in this situation, we have 4 equals a plus b. We could put equals 4 there from this result. So a plus b equals 4. So we have number 1 and number 2. It's definitely a simultaneous with elimination. So we'll get rid of our a's or b's. And in this case, it's easy to get rid of the b's. They're both the same. We'll take them away. Take. 2a take away a is a. These cancel. 10 take away 4 is 6. Therefore, a is going to be a value of 6. We simply sub in this a equals 6 back into any one of a or b, whatever looks easiest. In this case, probably number 2 does. So it'll be 6 plus what gives you 4. B hence would be minus 2. So sub into number 2. We've got 6 minus 2 will give you 4. That's what you want. Hence, therefore, b would be minus 2. So that's your answer. It'll be a 6 and b will be minus 2. We found out the values of a and b via simultaneous equations. Question 3 challenge. Let's press pause and let's write this quadratic inequality down. Let's try to do what we can on this. It's really extending our knowledge now on this topic. And let's press play when you've finished. So solve 1 minus x in brackets squared is greater than 4 over 25. The 3 steps simply still apply for this. Step 1, so let's solve this quadratic inequality over here. Whether it's a quadratic equation, whether it's dots, we don't really know it as yet. We know there's x squared involved. So let's put solve equation. Let's write this equal to 0. 1 minus x squared equals 4 over 25. Now, it's always a good idea to try to get everything equal to 0, because you know that if anything equals to 0, we can simply say it equals y, hence we can sketch this. It makes sketching much easier of the graph, i.e. stage or step 2. So to do this, what we'll do, we'll take this 4 over 25 to the left-hand side. We'll do 1 minus x squared minus 4 over 25 equals 0, okay? It looks in a better format now to sketch this, because remember, without sketching it, we can't really create these dashed lines. Hence, equaling 0 is a pivotal thing, actually, within this whole topic. Now, we're trying to look at this and think, okay, how can we make this look like, you know, a structure where we can solve this? Now, we have something over here that's giving us a hint. We have 1 minus x, which is being squared. And this is a squared term over here, squared fraction, 4 over 25. So could we possibly square root this, i.e. create 2 squared terms over here? Could we make it look like this? 1 minus x squared minus, we square root 4 and 25, 2 over 5 squared equals 0. Would that work? Are these the two same equations? Well, yes, they are. And the reason why we're looking at this is because this looks very similar to dots of this idea of, let's say, let's call it a and b, in fact. A squared minus b squared equals a plus b and a minus b. This is our basic understanding of dots. So hence a could represent this thing over here. We could say, therefore, you know, that a, if you look at this, see, a is equal to this thing over here, which is 1 minus x, and b is equal to this thing over here, which is 2 minus 5. Brackets, a equals 1 minus x. Okay, and b equals 2 over 5. If you see that subtle difference over there. So get this. If this is the case over here, let's try to color coordinate them, just to make sure you understand this, if that wasn't really clear. You know, 1 minus x, this a is 1 minus x, okay? And let's say the b over here, this b, 2 over 5, is simply this 2 over 5 over here. All right, so let's plug this in now, okay? So we've got this, and this might help you again, because we've got a and a here, and we've got b and b here as well. So if we understand the substitution, if a equals 1 minus x, we could say basically that this is the case over here. Let's follow this over here. We could say that so 1 minus x, which is a, plus 2 over 5, which is the b over here, okay, the whole thing, times a, which is 1 minus x again, but minus b, which is minus 2 over 5. This thing is the same as this over here, okay, so this is the same thing as this, equaling 0. They're both the same, because this is dots at its best over here. This whole thing is dots. If I want to highlight that, this is dots. Let me just do that. In fact, this is dots. See, this is dots over there. So let's try to work this out. Remember, this is not simple. That's why it's called a challenging question. So let's add all the numbers. What's 1 plus 2 over 5? 1 plus 2 over 5 is going to be 1.4, or 7 over 5. This can be non-calculator. So it'll be 7 over 5 minus x over here. And this would be, what's 1 minus 2 over 5? It'll be 3 over 5 minus x over here. And this is all equal to 0. We still haven't solved it. Therefore, x would simply be 7 over 5, or x would be 3 over 5. Right, now that looks complex. Let's do step 2. Step 2 is to sketch this graph, okay? And sketching the graph of in particular, we want to sketch this graph of, let's say, this over here. See this last bit over here? We're sketching that. So let's sketch the graph of this. 7 over 5 minus x, 3 over 5 minus x as well, equaling 0. We're sketching that graph. So x is 7 over 5, or 1.4 over here, and x would be 3 over 5, which is 0.6 over here. It's quite squashed up, in fact. So just a rough sketch of this. We're not too worried about where it crosses the y-axis over here. We're just going to roughly sketch this. It's a positive U shape as well, and roughly it'll look like this over here, here and here. Okay, we're not too concerned about the minimum point or turning point as well. Now let's do step 3. Step 3 is to create the dashed lines. So dashed lines would be this. We're really sketching this. 7 over 5 minus x, 3 over 5 minus x, all is greater than or equal to 0, because simply the original question had equaling 0 over here. Hence now we're bringing back the inequality sign in stage 3. So what will give us this? So anything greater than 0 will be these two quadrants over here. The x values that will satisfy y is greater than 0 would be these two quadrants over here. See, everything greater than here and everything greater than here as well. So the lines that have to be dashed would be these x values over here that would take place. Okay, because it's greater than 0. Hence, you'd want all the values that are over here greater than this, or all the values that are less than this over here. So let's read off the graph. The dashed lines on the green bits, it'll simply be x is greater than 7 over 5, or x is less than 3 over 5. Those are your two values for this. So again, the tough bit really was stage 1 into identifying or putting this, subbing this into a dots format. But once you've got that, it's the same procedure as the 3 steps for any kind of quadratic inequality. Look back at this question and make notes on your revision cards if you need to. But if you get this, you more or less understand quadratic inequalities to its maximum level.